Today we're looking at our trigonometric review for Module 13. So we've got our celebration of learning coming up, and these are the things you need to know. So you've got the first four problems are our special right triangles. So as you're looking at that, picture in your head the relationship between the sides. If you've got the 30, 60, 90, you know that the long side, or the hypotenuse, is 2 times x. That means that 15 will be 2 times x. So x would be 15 halves. And if you're looking, your short side is here. This would be 15 over 2. Now, to go from your short side to your long side, you just simply multiply that short side by the square root of 3. So for your long side, the long side's across from the 60-degree angle. This becomes 15 square root of 2 divided by 2. And you're done. For the next one, here's your 60-degree angle. This is your long side. So if we're looking at the long side, it's a number times the square root of 3. It's actually going to be y, because y is the short side. So we're looking at y times the square root of 3 is going to be equal to 6. Divide both sides by the square root of 3. Remember, we cannot leave that radical in the denominator. We're going to multiply by a really funny looking one. I'm going to multiply by the square root of 3 divided by the square root of 3. Squaring and square rooting undo each other. This is actually, if you're looking at this is the square root of 9, which gives me 3. So this becomes 6 square root of 3 divided by 3. 6 divided by 3 is 2, and this becomes 2 square root of 3. To go from our short side to our hypotenuse, here's our short side, here's our hypotenuse, we multiply by 2. So this becomes 2 times 2 square root of 3. And this is 4 square root of 3. For the 45, 45, 90, we know these have to be the same because we've got the base angles of an isosceles triangle, so these two legs have to be the same. If I'm looking at what my diagram tells me, if this is x, this is x, this is x square root of 2. So I know that 9 is equal to x square root of 2. Just like what we did here, we're going to divide by the square root of 2. So 9 is divided by the square root of 2 is equal to x. We're going to multiply by the square root of 2 divided by the square root of 2, which is 1. Okay, 9 over the square root of 2. times the square root of 2 over the square root of 2 gives me 9 square root of 2 divided by 2. Remember, this will be the square root of 4, which gives me 2. And for the last one is actually the easiest one. All I have to do, I know that if this leg is 5, the other leg has to be 5 also. And this is 5 times the square root of 2, and I'm done. Okay, draw a picture that models each polygon to aid in finding the desired measure. Find the exact perimeter of a square with a diagonal of 12 inches. So the first thing I'm going to do is to draw that square. Now, as you can see, I'm in a hurry, so I've got to tell you that this is a square. I'm going to put those 90-degree angles there. Here is my diagonal. This is 12. So, what is the length of each side? If you notice, this has got to be the 45, 45, 90-degree triangle. And I've got the hypotenuse. I'm looking for a leg. The hypotenuse is 12. So that is equal to x times the square root of 2. Once again, divide by the square root of 2. 12 divided by the square root of 2 equals x. 12 divided by the square root of 2 times the square root of 2 over the square root of 2 equals 12 square root of 2 divided by 2, and I end up with 6 square root of 2. And I need the exact perimeter. Each of these sides are 6 square root of 2. What do I know about the sides of a square? They're all the same. So for my perimeter, it will be equal to 4 times 6 square root of 2. So my perimeter is equal to 24 square root of 2. And that would be inches. So, hopefully that was helpful to you. Let's look at the next one. Once again, I've got the square. I'm going to make this one a little bit smaller. So you can tell I have a hard time making those right angles without using a compass. Okay, now what I know, I know that all of these are the same. And what I am looking for is that diagonal. Once again, what kind of triangles have I formed? The 45, 45, 90-degree triangle. So my perimeter is 20 feet. That means when I add all 4 sides together, I get 20 feet. So I'm going to divide by 4, and I know that each side is 5 feet. So this will be x square root of 2. This is x. So my diagonal will be 5 square root of 2, and that will be feet. If you're still struggling with the idea, please back up and watch it again. So let's look and think about which ones it could be and then decide if it is or not. So if I'm looking at this, the biggest side is 7. This has the square root of 3 in it. So automatically, I know if it's going to be one of the two, it will be my 30, 60, 90 degree triangle. So is 3 halves, 3 and 1/2, half of 7? Yes. So if this ends up 7 square root of 3 divided by 2, this is a 30, 60, 90 degree triangle. Once again, you're looking at the square root of 3. Does this work? Okay, so my short side's 8. My long side is 8 square root of 3. My hypotenuse is 16. 16 is 2 times 8. My long side is 8 times the square root of 3. That also works. Let's look at the next one. 8 over 11 would be your smallest side. 8 square root of 3 over 11 would be your long side. Is 1 and 5/11 the same as 16/11? Because it would have to be 2 times 8. So let's look at the way we would work this. 1 and 5 over 11 is equal to 11 times 1 is 11, plus 5 is 16. 8 over 11 is half, 16 over 11 is twice the 8/11. Add the square root of 3, and this would be a 30, 60, 90 degree triangle. For the last one, square root of 2, it is definitely 45, 45, 90. Okay, once again, we're dividing by that square root of 2. So I'm going to multiply by the square root of 2 over the square root of 2. 11 square root of 2 over 4. Or over 2. As you can see, that is the middle number. So 3 of them were the 30, 60, 90 degree triangles, and one of them was 45, 45, 90. Okay, determine the value of x. When we're looking at finding an angle measure, do you remember which button we use? So, what we need to do is to remember that acronym. So, TOA. If my angle's here, what two pieces do I have? Do I have my hypotenuse? No. So that eliminates sine and cosine and leaves me with tangent. The tangent of x degrees is equal to my opposite, O is opposite, 120 divided by my adjacent, which is 126, Now I use my tangent inverse of 120 divided by 126, and it is approximately second tan 120 divided by 126, 43.6 degrees. Okay, for the next one we are looking for what? A leg or the hypotenuse? Well, we're looking for the hypotenuse. If my angle is here, is 36 my opposite or my adjacent? It's my adjacent, so I'm looking at cosine. The cosine of 38 degrees is equal to 36 divided by x. What happens when the variable's at the bottom? We switch them around. X is equal to 36 divided by the cosine of 38 degrees. That is approximately 45.684. That would be 45.7. And that would be meters. That's the units we're in. It's important to use your units when you are doing geometry. Okay, for the last one. Do we know the hypotenuse? What two pieces do we know? Do we know the hypotenuse? Yes. Here's my angle. Is x opposite or adjacent? It's opposite. Opposite and hypotenuse is sine. The sine of 23 degrees is equal to x divided by 322. Okay, I've divided by 322. What is the opposite? Well, that is to multiply by 322. (322) times the sine of 23 is equal to 125.8. So it's approximately 125.8. And this would be in centimeters. Okay, for the next one, draw a picture to illustrate the scenario. Write and solve an equation to find the desired measurement. To be safe, the angle of elevation between a ladder and the ground should be 75 degrees. A 30-foot ladder could safely reach the top of a building that is how tall? Round to the nearest tenth of a foot. So, to be safe, your angle of elevation is 75 degrees. You're looking at a 30-foot ladder, and you're wanting to know how tall the building would be. Let's make a picture. Here's my building. Here's my ladder. My ladder is 30 foot tall, and I have a 75-degree angle, and I'm wanting to know how far from the building I put it. Step 1, am I using sine, cosine, or tangent? This is my hypotenuse. This is my adjacent. Adjacent and hypotenuse is sine. So the sine of 75 degrees is equal to something divided by 30. The opposite of dividing by 30 is to multiply by 30. So in my calculator, 30 times the, oh, is that what we're looking for? We're not looking for the distance away. We are looking for the height of the building. This becomes the opposite over the hypotenuse, which is a sine, but I just had the x in the wrong spot. Thirty times the sine of 75 is 28.977, which would round up to 29 feet. The building is about 29 feet tall. That would be as high as you'd want to go with that ladder. Okay, a man spots a swimmer in a lake. The swimmer is 300 yards from the base of a cliff. If the angle of depression from the top of the cliff to the swimmer is 38 degrees, how tall is the cliff? So as I draw the picture, here's my cliff, here's my swimmer, the angle of elevation, or angle of depression, is 38. How tall is the cliff? We know that he's 300 yards from the base. This is what we're wanting to see. We know that the angle of depression is 38 degrees. Now what? Well, we've got those alternate interior angles, so this one is also 38 degrees. Question number 1. Am I using my hypotenuse? No. If I don't use my hypotenuse, that leads me to only one of my trig ratios, which is tangent. So the tangent of 38 degrees is equal to x divided by 300. I've divided by 300. The opposite is to multiply both sides by 300. .300 times the tangent of 38 is 234.38. So that's about 234.4. So the cliff is about 234.4 yards tall. An airplane descends 200 feet for every 1 mile traveled horizontally. Find the airplane's angle of depression to the nearest degree. Remember, 1 mile equals 5,280 feet. So if we're looking at this, what's going on? If we're in miles and feet, we have to have them both in the same units, which means that this mile has to be converted to feet. But let's highlight. So it descends 200 feet for every 1 mile. And wanting the angle of depression. So here we go with our airplane. Okay, so for every 1 mile traveled horizontally. So this is your horizontal. This is 5,280 feet. And it drops 200 feet. What I'm wanting is this angle of depression, but I know that these two are the same. How do I do it? Sine, cosine, or tangent? I know nothing about my hypotenuse, so it's got to be the tangent. The tangent of x degrees is equal to, my opposite is 200, divided by 5,280. And you use what? You use the inverse button. 200 divided by 5,280 is approximately. Second, tangent. 200 divided by 5,280. And I get approximately 2.169. So it's approximately 2.2 degrees. So the airplane's angle of depression is about 2.2 degrees, 2 2/10 degrees. And for the last word problem, a man is hunting squirrels in trees. He spots a rare albino squirrel that is 15 feet up in the tree. If his eye level is 5 feet 8 inches and it needs to look up with an angle of elevation of 22 degrees, how far of a shot would that be measured from his eyes? Okay. This is 14 feet up. Here's his eye level, angle of elevation. Okay, now remember, this is not angle of elevation is 22 degrees. Okay. What do you notice? I've got feet and inches and I've got feet. So I either have to change both of them to feet or one of them to feet and one of them or both of them to inches. Inches is definitely the smarter move. So 5 feet 9 inches is equal to 5 times 12 plus 9, which is 69. So this from here to here is 69. 14 feet. 14 times 12 is equal to 168. So to find this distance here, I need to take 168 minus 69, and I get 99 inches. Now I'm ready to solve. I'm looking for my hypotenuse, and I know my opposite. Opposite and hypotenuse is your sine. So the sine of 22 degrees is equal to 99 inches divided by x inches. Once again, if it's at the bottom, what do? We flip them around. So x is equal to 99 divided by the sine of 22. And this will be an approximation again. $264.3. And that will be inches. If I want to change it to feet, I'll divide it by 12. And I get 22.02. And that I wouldn't count the .02 because that's such a small amount. Okay, any questions? Okay, so I actually had the pages mixed up, so you'll have to go back a page, find the value of x, and write your answer rounded to the nearest tenth. Sine, cosine, or tangent. Once again, we are using SOHCAHTOA. Will I need sine, cosine, and tangent for this? Nope, I can actually use the Pythagorean theorem. A squared plus B squared equals C squared. I know my C, so I will be subtracting. So B squared is equal to C squared minus A squared. So x squared is equal to 20 squared minus 14 squared. The opposite of squaring is square rooting. X is equal to the square root of 20 squared minus 14 squared, and I get 14.28, which is approximately 14.3. We don't know what units it's in. So for the next one, we know that the hypotenuses are 11. We're looking for a leg. If the whole thing is 8, what do we know about each of these pieces? Each of those pieces will be 4 because it will cut it in half. Once again, I know the hypotenuse. I'm looking for a leg. So x squared is equal to the square root of 11 squared minus 4 squared. Square root both sides. You end up with 10.24, which is approximately 10.2. Okay, for the next one, you've got a right triangle. You know two pieces. You know one leg is 12 inches, one leg is 19 inches. What is the third side? What are the two possible lengths you could have? Well, if you're looking at it, if both of these were the legs, it would be a squared plus b squared equals c squared. 12 squared plus 19 squared is equal to c squared. You would square root both sides. And now I've got 12 squared plus 19 squared, and I end up with 22.5 about. In this case, I used that third side as my hypotenuse. But what if it was a leg? Well, the same thing's going to happen, only this time you're going to have to subtract. So I'm going to say a squared is equal to 19 squared, because it's the largest one, minus 12 squared. The opposite of squaring is square rooting. Nineteen squared minus 12 squared is 14.7. So, looking at that, you now have two lengths, possible lengths it could be. For the next one, sine, cosine, and tangent. This is obviously a 30, 60, 90 degree triangle. So what for your sine? Sine is opposite, and we're from A, opposite, over hypotenuse. 6 square root of 3 divided by 12. Okay, 6 goes evenly into the top and bottom. This becomes the square root of 3 over 2. For the cosine of B, your cosine is the adjacent over the hypotenuse, which is what we just did. 6 square root of 3 over 12, and we end up with the square root of 3 divided by 2 again. Your tangents will be opposite reciprocals. They'll be reciprocals, not opposite like what we do for perpendicular lines, but these will simply be reciprocals. The tangent of A, 6 square root of 3 divided by 6. That is simply the square root of 3. Now, when I turn them over, I'll have 6 divided by 6 square root of 3. The 6's cancel out, so I get 1 over the square root of 3. But I can't leave it that way. So I'm going to multiply by the square root of 3 over the square root of 3. And I end up with the square root of 3 divided by 3. for the last two. They're not the last two, but they're the last two we're going to do. We're finding measures. We want that acute angle measure. So if I'm looking at angle F, what are the two sides that I can find? I can find the length of D and I can find the length of F. How am I going to do that? Simply by counting. 1, 2, 3, 4, 5, 6, 7, 8. This side is 8. 1, 2, 3, 4, 5. This side is 5. So I'm looking at the tangent. So it will become the tangent inverse. My tangent is 8 over 5. Second tangent. 8 divided by 5, and I end up with 57.99, so it's about 60 degrees. Okay, for the length of DF, that's your hypotenuse. This is your right angle. I know that this is 60 degrees. Do I want to use sine or cosine? Doesn't matter. If I use the sine, it'll be 8 over x. If I use the cosine, it'll be 5 over x. So if I'm looking at this, this would be my short side, long side, and hypotenuse. This is actually 57, not 60. 57.99, which would be 58. I rounded the wrong one, rounded up too far. So this is 58. So I'm going to use the sine of 58. Degrees is equal to 8 over x. Swap them around. X is equal to 8 divided by the sine of 58 degrees. And that is approximately 9.4. Okay, now for the last one, find the length of the third side of the triangle to the nearest inch. So if we're looking at this, we don't know the height. If I cover all this up, I see I've got a right triangle, I've got the hypotenuse, and I've got an angle. If this is my height, I know that my area is your base times your height divided by 2. I'm looking for my height. This one will be my base. If I cover all this up, I've got this angle and I've got the hypotenuse. This is my opposite. Opposite and hypotenuse is sine. So the sine of 77 degrees is equal to h divided by 14. Multiply both sides by 14. Times the sine of 77, and I get 13.64. and that's approximately my H value. Now, to find the area, I'm going to put it all together. .33 times 13.64 and divide it all by 2. So, as I put it into the calculator, 33 times 13.64 divided all by 2. Order of operations will do it correctly. 225.06. So my area is about 225.06 inches. You're to round to the nearest inch. 225, and this would be inches squared. So hopefully you were able to get it all done. If you didn't, watch the video again on the parts you are still struggling with.